So here in section 9.1, we're talking about rational functions, right? This is the last one we're going to talk about for the year. We've talked about a lot of other types of functions. We know trigonometric functions, we know quadratic functions, cubic functions, linear functions, right? All of these. We even just got done talking about exponential and logarithmic functions. So these are all types of functions. And I first want to start talking about the parent function for rational functions. And so the parent function is written as y equals 1 over x, and the graph of it looks something like this. Now you might notice, well, it kind of looks like a logarithm or an exponential function or something like that. And when we look at the graph, we notice that it has both a horizontal asymptote and it has a vertical asymptote. All right. And so because we have a vertical and a horizontal asymptote, we want to think about what they are and where they come from, and we want to kind of compare it to the other functions we've talked about so far this year. So we can see in this problem that the horizontal asymptote is a horizontal line, so it's got to be y equals a number, and it's right on the x-axis, so the height is 0. So y equals 0 would be the horizontal asymptote. The vertical asymptote is, again, a vertical line, so it has to have the equation x equals a number, and because it's right up and down on the y-axis, it's also x equals 0. All right. So when we graph these rational functions, we're going to have to figure out what is the vertical asymptote and what is the horizontal asymptote. And so if we think about, in general, the equation, we're going to do this after we look at this example here. We want to, again, kind of use some deductions here to think about what we can describe and how we can describe the vertical and horizontal asymptotes. So if we look at a problem like this, this is the equation y equals 2 over x minus 6, and then we're going to add 4 to that. This is a rational function, and it appears like this graph here. And so if we look at this graph, we can see that we have kind of a vertical asymptote here right on this line, and it looks like this is the vertical line x equals 6. Right down there. That graph will never touch that vertical line. And if we look at this horizontal line here, we can see that this graph is never going to touch this horizontal line, and this horizontal line is at 4. So y equals 4. All right. So I want you to take a minute and think about how these vertical and horizontal asymptotes relate back to our rational function. All right. So just take a minute, take a look at that, and think about how those relate to each other, all right? So now when we talk about, in general, the form of a rational function, as well as the general equation of the horizontal and vertical asymptotes, we can use our knowledge of the previous functions that we've learned. Here are just 2 of the ones that we've talked about so far this year. We know we're going to have the letter A, the letter H, and the letter K. All 3 of these are involved. We know that A tells me whether the graph is trending upwards or downwards. We know that H tells me how it moves left and right. K tells me how it moves up and down. All right, so these 3 factors we have to piece in. And if we look, we know we're going to start with y equals, and we're going to have a fraction. And so if we think about A, we always know A is what's multiplied by this function. So A is going to go in the numerator, A times something. All right, we could put it out in front, right, like A times this, but A times a fraction is the same as just placing A in the numerator. And then we want to shift the x value by h. So we know that x is in the denominator, and I want to shift it by h units, right? That's going to shift me left and right. And then we know that k is how much I shift up and down, and so we're always going to have this plus k at the end. So this, in general, is the setup of all of our rational functions. And again, if we look at trying to identify the horizontal and vertical asymptotes, hopefully you saw in this previous one that the vertical asymptote comes from the h value and the horizontal asymptote comes from the k value. So what we can say is that for the horizontal asymptote, y equals k, and for the vertical asymptote, x equals h. All right? This should remind you of logarithmic functions. The horizontal asymptote, that should remind you of exponential functions, all right? So these are going to be kind of the key pieces of information that we have to remember, because we're going to be asked to graph these things. So if I'm asked to graph this problem right here, y equals -3 over x plus 2, a good strategy might be to first identify the vertical and horizontal asymptotes. So we're going to say that we know the horizontal asymptote is always y equals a number. It's a horizontal line. And I can always find it based on the k value. And so we see a plus 2 here. So y equals 2. That means I'm going to draw a dotted line right here at 2. All right, so it's never going to cross this line here. And then we're also going to think about what is my vertical asymptote. All right, and my vertical asymptote always is x equals a number. But if we look down here, notice there's nothing alongside the x, right? There's really a 0 over here. So we know that the vertical asymptote is going to have the equation x equals 0. And x equals 0 we know is a vertical line, and it's a vertical line right on the y-axis. All right, so there we go. Now the question is, how is this graph going to be, right? The ones we've seen so far have been curved, in the kind of first and third quadrant directions, as we see here as well. But we know that A is going to make it negative, right? If A is negative here, it's almost going to flip-flop this graph. And so instead of it being here and here, we're actually going to have it here and here. And again, the reason is because A is negative, right? But you can always test this out if you're not sure. And at this point, this is a great time to make a table, all right? Once you've got your your vertical and horizontal asymptotes, always a great idea to plug in some points, all right? So I'm going to pick some numbers. I don't want to pick 0, right? Because I know 0's not allowed. That's an asymptote there. So I'm going to pick something like, let's try, how about -1? So if I plug in a -1 for x, that would be -3 over -1 plus 2. And this comes out to be 3 plus 2, which we know is 5. All right, so I'm going to get rid of that. And we can graph the point -1, comma 5. And that puts me right there. Let's try another negative. Let's try, how about let's try -3, how about? If I plug in a -3, we get -3 over -3 plus 2. Well, this is just 1 plus 2, which we know is 3. So we're going to go ahead and graph that point, -3, comma 3. And there we are. All right, so we know that this part of the graph is definitely going to curve just like this, all right? Making sure that we don't cross the red dotted line or the blue dotted line. And then I can keep going with this table of values. I'm going to continue down here a little bit. I'm going to pick 2 more numbers, but again, I want to choose something over here and see what happens over here. So I'm going to pick +1, and if I plug in a +1, we get -3 over 1 plus 2. This is -3 plus 2, which comes out to be -1. So I know that when I graph this, we're at 1, comma -1 right there. I can plug in another number. 3 would be a good number to choose. Again, I want to make this kind of easy to solve, so picking a number like 4 or 5, I have to deal with fractions. So I'm going to pick a number that's easy to me, that makes that reducible. So -3 over 3 plus 2, that's -1 plus 2, which is just +1. So we can go ahead and graph that point as well. And once we graph that point at 3, comma 1, we should be able to clearly see that this part of the graph is going to curve in this direction. Again, it's just going to kind of hug those asymptotes as we go along. All right, so I want to see at least 1 point in either of these quadrants just to make sure. It is possible to have, sometimes I'll do this in purple, it is possible to have graphs that curve like this and then again like this. So don't always assume that, oh, if it's in the top left over here, then it has to be in the bottom right. That's not always true. It could vary. So just be careful whenever you've got your asymptotes already figured out, make sure you test out a point somewhere in this region and then test out a point somewhere in this region to make sure that they are actually going opposite each other like this. All right. This next problem is a little bit different. It's kind of reverse engineering. So here we're asked to determine the equation of the hyperbola. Hyperbola is a new word here. You maybe haven't heard of that. Hyperbola is just this shape. All right, so all of our rational functions for now that we're talking about are going to have this shape, which we call a hyperbola. All right. Given a horizontal asymptote of y equals 5, a vertical asymptote of x equals 4, a -4, and it has a y-intercept of 0, -8. We then want to identify the domain and the range, all right? When I look at a problem like this, I know that the horizontal asymptote is y equals 5, and I know that the vertical asymptote is x equals -4. All right, so I'm going to start with that information. We know that the general equation is y equals a over x minus h plus k. All right, so where I can use the 5 and the -4 here come in the h and the k values. So because the horizontal asymptote is 5, I know that I'm going to replace the k with the 5. And because we know that the vertical asymptote is a -4, we're going to replace the h with a -4. Now be careful here, right? If I take a -4 and I plug it in here for h, we're going to have x minus -4. And so like we've learned this whole year, h value always looks different than what it actually appears to be. So we're going to have a over x plus 4, and then all of that plus 5. All right, so we've gotten the horizontal asymptote taken care of, right? We replaced the k with 5, and we've gotten the vertical asymptote taken care of. We replaced h with -4. But we haven't quite figured out what this equation is because we still have an a value here. And I don't want to have that a value, I want to have a number. And this is where the y-intercept comes in. All right, so because the y-intercept is 0, -8, what I'm allowed to do is replace the x value with 0 and replace the y value with -8. So if we do this, we get -8 equals a over 0 plus 4 plus 5. All right, so again, we're trying to figure out what that a value is. So after I replace the x with a 0 and the y with a -8, we should be able to solve this for a and figure out what that a value is going to be. So if we do this, we've got -8 equals a over 4 plus 5. I'm going to go ahead and subtract 5 on both sides. All right, so this means we've got -13 equals a over 4. And then I'm going to go ahead and multiply both sides by 4. And we get -68 equals a. All right, so a is going to equal -68. So pulling it all together, we're going to have the equation y equals -68 over x plus 4 plus 5. All right, and so that would be the equation of the line that has a horizontal asymptote of 5, a vertical asymptote at -4, and it also goes through the y-intercept of 0, -8. All right, so that's how you're going to have to go ahead and solve these types of problems. Make sure you're just plugging in the asymptotes and then your y-intercept. If they give you a different point besides the y-intercept, you'd still plug it in for x and y. Just might not always be a 0 and a -8, but that is still the same process. Okay. One last thing is to find the domain and the range. So I actually want to start up with this one, finding the domain and the range. To find the domain and the range, again, domain is all of your x values, range is all of your y values. So if I look at all my possible x values, it's basically I can go left forever and I can go right forever, except at whatever your vertical asymptote is, right? We know that that red dotted line is not allowed for my x values. So I want to think of a way to describe every single x value except the x value at that red dotted line, at your vertical asymptote. So basically, I'm trying to describe from -infinity up to 0, and then separately from 0 up to infinity. All right, so the best way I could do this is in interval notation. I say, hey, I go left forever, but then I stop when I get to 0. I don't include the 0, so I put a parenthesis. And then I skip past 0, and I go from 0 up to positive infinity. The range is the same kind of idea, right? As I move up and down, I'm saying, hey, I go up forever, and I go down until I get to this blue dotted line. That's my horizontal asymptote. I skip over 2, and then I continue until I go down forever to -infinity. So for my y values, we're saying, well, I can go down forever, but then when I get up to positive 2, I have to stop and skip over it, and then I continue on to infinity. All right? So again, what this domain really means is every single value except 0. And what the range means is every single value except 2. So hopefully you've noticed that it's basically all real numbers. You just have to write it in a way that skips over your horizontal and vertical asymptotes. All right, so I can add the colors here. You can see that for the range, you're skipping over the horizontal asymptote, and for the domain, you're skipping over the vertical asymptote. So if we apply that same concept here to this problem, because we know the horizontal asymptote is y equals 5, and because we know the vertical asymptote is x equals -4, we can use this same logic to find the domain and the range. We don't even need to draw a picture, right? My domain has to skip over the -4, so I'm going from -infinity to -4, skipping over it, and then continuing on to the right to infinity. The range, I have to skip over that horizontal asymptote. So I'm starting down at -infinity, but I'm skipping over that 5, and then I'm continuing on upwards forever to positive infinity. All right, so that's your equation, and then this would be your domain and